Okay, so let's have a look at calculating the pH of weak acids and bases. So we started by just listing off a couple of weak acids that you're going to encounter. Methanoic, ethanoic, propanoic acids, and we've got the formulas there for them as well. So once you see those, you know you're dealing with weak acids and bases. Now, why do we have to distinguish between weak acids and bases? Well, we've already looked at how to calculate the pH of strong acids and bases, and it was done a particular way. When you're working at the pH of weak acids and bases, there's another way of doing it, and indeed another formula. So the formula that we're going to use for calculating the weak acids and bases is the following. So the first thing you're going to have to find is you're going to have to find the hydrogen ion concentration, and we've got a formula that will work that out for us. So your hydrogen ion concentration is equal to the square root of Ka multiplied by M acid. So let's go through this and see what each one of the parts means. Well, we know what the hydrogen ion concentration is. Your Ka, which is here, this will be given in the question for the most part. Sometimes it won't be given in the question. We'll figure out how to do that. And then, of course, we have M acid, which is the concentration of the acid, or the molarity of the acid in moles per litre. And then H plus then is your hydrogen ion concentration. So let's see how we're going to figure out how to do this question. Looking at the first question, calculate the pH of a 0.1 molar solution of methanoic acid, given that Ka for the acid is 2.1 multiplied by 10 to the minus 4. So the first thing I'm looking at here is we're asked to find the pH, and we know that it's methanoic acid. Methanoic acid is a weak acid, so we're going to start with our formula, which we've got here. So Ka is going to be in our equation, so we're going to start with H plus is equal to the square root of Ka multiplied by M acid, molarity of the acid, and you fill in your numbers. So putting that in, we've got the square root of 2.1 multiplied by 10 to the minus 4. So that there is Ka. And then we're going to multiply it by the molarity of the acid, which is 0.1 according to this question here. And then you put that into your calculator and you're going to get 0.00021. And then you work out the square root of that, which will give you your H pluses. So that means your hydrogen ion concentration is going to be equal to 0.0046. I'm working it out here on my calculator. Now this isn't the final answer because the question is asking you to find the pH. We haven't found the pH. All we've done is found the hydrogen ion concentration. But now that we have the hydrogen ion concentration, we can find the pH as normal. So pH is equal to minus log to the base 10 of the hydrogen ion concentration. So pH here is minus log to the base 10 of 0.0046. And that's going to give us a final answer of 2.34. So that is the pH of that particular acid. Let's try with another one. So the next one, find the pH of an aqueous solution containing 1.48 grams of propanoic acid. So again, a couple of things. I will be having a look at propanoic acid, so we know it's a weak acid. We're also given Ka, so that's also another hint of what we've got to use. But there is other difficulties here. So let's put down our formula. Our H plus ions, we have to use this, is going to be the square root of Ka multiplied by the molarity of the acid. So we're going to pop in Ka. So we have Ka as 1.36 multiplied by 10 to the minus 5. There's our Ka. And we're going to multiply that by the molarity of the acid. Now when we come back up to our question, we can see that it doesn't give us the molarity. However, it does give us that it contains 1.48 grams in 200 cm cubed. So you have to work out the molarity on the side. So we've got 1.48 grams of propanoic acid, which is C2H5COOH, and that's in 200 cm cubed. Now, if you want to work out the molarity of this substance, it has to be moles in a litre, or moles in 1000 cm cubed. So the first thing we've got to do is we've got to change your grams to moles. So this one here, to go from grams to moles, you're going to divide by the molecular mass. So the molecular mass of C2H5COOH is going to be, well, let's work it out, 74. So 1.48 divided by 74. So we're going to get 0.02 moles of C2H5COOH in 200 cm cubed. So we have moles, but we need litres. So obviously, if we want to turn that into litres, we've got to multiply it by 5. So we end up with 0.1 moles in 1 litre. And once we have moles in 1 litre, or moles per 1000 cm cubed, then that's a 0.1 molar solution of C2H5COOH. Now, in the question, this is actually written as CH3, CH2, COOH, but it's the same thing. So now we can go fill in our concentration. The molarity of our acid is 0.1. So when you work that out, that's going to be 0.0012. Now again, that only gives us the hydrogen ion concentration. We now have to go find the pH. So as usual, you take your pH formula. So pH is equal to minus log base 10 of your hydrogen ion concentration. And you pop that into your calculator and you get your final answer. So that's giving us a value of 2.92. So that's the pH for that solution. Let's move on to the last example. So we got the dissociation of the weak base ammonia. Now, it does tell you that you have a weak base. So again, that should be a hint. But also, ammonia is a weak base, even if it didn't tell you it was a weak base. It says find the pH. It gives us the concentration, and it gives us, instead of Ka, which would normally be Ka for acid, this is Kb for base. So let's work down through this. Same thing again, except this time, instead of going the H plus ions is equal to Ka multiplied by the molarity of the acid, because we're changing this around, and it's a base, you're actually going to be doing the OH minus ions. And that's going to be Kb multiplied by the molarity of the base. So it's the same formula, but just changes very, very slightly. So again, OH minus ions is going to be the square root of Kb multiplied by the molarity of the base. So let's see if we can figure out Kb. Kb is there as 1.8 by 10 to the minus 5. And you're going to multiply that by the molarity of the base. The molarity of the base is 0.01, and you're going to get the square root of the whole lot. So you eventually end up with OH minus ions. So the OH minus ions is coming in at 0.00042. And again, this question is asking us to find the pH, so it's not enough just to have that. So pH is minus log to the base 10 of the hydrogen ion concentration, but we're dealing with a base, so the hydroxyl concentration, but it's done the same way. It's minus log to the base 10 of 0.00042. So that's going to give us a pH value then of 3.38. Now, as we can see, that this here is not basic. This is actually an acidic number. So obviously we've done something wrong. So to work out our pH is basically 14 minus your pOH, which is that. So we've got 14 minus 3.38, and our actual pH finishes out at 10.62. So that's the pH then for working out a base.